Differentiation of y would be what? We took a question which is y is equal to 1. This question. It is not difficult to solve it. Y is equal to 1. Y is 1. Then what should be differentiation of this? Remember, word of differentiation will be like that. Differentiation. Differentiation. DIFFEREN. Differentiation. Okay. You know that this is nothing but just dy upon dx. Dy upon dx. Any number you are getting as a y, any number you are getting as a y will be known as a constant. When you will differentiate this, then you will get 0, because here constant number is coming. Constant, it can be any number, 50, 60, 70. This is not with variable, isn't it? This is not with variable. So any number which is alone without any variable will be 0 at the end after differentiating. Okay, after doing differentiation. So here we will solve. Then what will happen? dy upon dx. dy upon dx. So we are going to do differentiation of y. So in place of y we will put 1 and dx will be as it. Dx will be as it. Now we know that differentiation of any fixed number will be nothing but 0. That's it. Will be nothing but 0. Same here. Your next question can be y is equal to 33. In that case, dy upon dx is your how much? 33. So here you are doing what? You are doing differentiation of y. So 33 upon dx will be what? 0. Any number which is fixed will be at the end after doing a differentiation will be giving us what? 0 constant. 0 constant. In this you understood any constant number will be 0 after doing differentiation. Next I will write next is that y next is y is equal to x raised to power 5. X raised to power 5. How to differentiate it? Question is y as x raised to power 5. This is very easy. It is very easy. Look at over it. Just write dy upon dx. In this you are doing you are differentiating y. Okay, you are differentiating y. So look at over here. Y is how much? X raised to 5. It is in bracket. This is in bracket. Then P upon dx. Now you know that if this is like that and this is a natural number, or it can be whole number, integer number. Here this is number. This is number. In that case, this power will come downward. Then x as it. Just here, I will subtract this by minus 1. By minus 1. So this will be your output, and this is your input. In that case, in this case, what is happening? X, okay, and here 5. Both are same. Just we will apply this formula over here to solve this. Here you can see we wrote n as a base, and then we subtracted n exponent by minus 1. Same here we will do with this 5 exponent. We will write in the place of base. So 5x, and as you know that we will subtract the exponent by 1. 5 minus 1 will give you 4. So this is your final answer. After doing differentiation to it, we got this much. So this was input and this is the output. Output is a 5 into x raised to power 4. That if a question is like that, that kind of a question are coming, then you will apply this formula. Then your result will come. Next question I will type. Next question. If y is a sin x, in that case, just this is just formula. Okay, this is just a formula. This is just a formula here. Look at over here. Pi as a sin x. In that case, solve this dy upon dx. Here you are doing differentiate. You are doing differentiate this. Then sin x upon dx. What is the differentiation of a sin x? Just cos x. Okay, just cos x. Cos x. This is your answer. This was a formula. Differentiation of a sin x is always a cos x. Clear? Now next. What if y is a cos x? Okay, y is a cos x. In this case, y was sin x, but in another question, y is cos x. And what will happen? Just to solve this, dy upon dx cos x d into cos x upon dx. So here we are saying that differentiation of cos x is always what? Just opposite of this sin x. Okay? This is your result. Sin x. So depreciation of the sin x would be cos x. Just opposite. Reverse. Depreciation of the cos x will give you sin x. Clear? Now next there is a twist in the next question. The twist is that if y is e raised to power x, okay. If this is coming, in that case this will be as it. In that case this will be as it. Yes, in the place of x it can be number, I think so. Okay. If e is coming like that, e raised to power x, then in that case you will realize that this we will be writing this as it. Nothing will be changed in that case. So solve this. Here look at over here. Dy upon dx. Okay, we are representing this. So d e raised to power x upon dx. So this will be as it. If this is how much? I think if this e raised to power 10, in that case what will happen? I think it should be dy upon dx is equal to d raised to power d into e raised to power 10 and dx. It should be as is. That is what I am trying to tell you. Okay, this will be as it. Now next. Y is ln x. Then what is the differentiation of ln x? What is the differentiation of ln x? Just dy upon dx. And here we are differentiating this. ln x. Remember, differentiation of ln x will be nothing but just 1 upon x. Just 1 upon x. Clear? 1 upon x. Just a reciprocal of x. Okay. So what did we say? Here we say that if a constant is y is a constant, okay, constant. Whatever we saw, I am just repeating right now. If y is a constant, in that case, differentiation will be what? 0. Differentiation output would be 0. Remember, okay, output would be 0. Now this one we saw. Second, if y is a sin x, then differentiation of this would be just cosec x. If y is cosec x, then differentiation of it would be just a sin x, just a positive of this. But we saw that if y is e raised to power x, then it will be written as it. It would be as e raised to power x. The next, Next, we saw y. If y is as ln x, in that case, just reciprocal of x will be output. Clear? The next we saw, yes, one thing more is that if y is equal to x raised to power n is a number. Okay, n is a number. In that case, this n will come in the place of in the place of a base. X as it, we will subtract n by minus 1, n minus 1. Clear? Now one thing more is that if y is 1 upon x, y is 1 upon x. So here you can simplify it. After simplifying it, you will get x raised to power minus 1. X raised to power minus. Now you are able to apply this formula in this. What will be output? Output would be nothing but minus 1 x minus x, then minus 1 and minus 1 will give you minus 2. This is your result. Clear? So right now we saw all this. Apart from this, there are more that we are going to explore. Just have a look on this. Here, first rule we are going to explore. First rule. First rule with fission. First rule with fission. This fission. Now look at over here. If y is giving you multiplication and addition, here you can see 2 is in multiplication and this operator is coming addition. In that case, what will you do if operators are coming in that case? So here just do whatever is possible. Just to do whatever is possible. It is a graph, but here we are going to solve it in mathematics rather than drawing a graph. There are two ways to solve this. First is through graph and second is through mathematics. So here through mathematics we are solving. Equation y is 2 sin x plus b, and how to differentiate it? I am showing you. This dy upon dx. Okay. First of all, this 2 will be as, because it is in multiplication. That's why this is in multiplication. this is sin x will be differentiated. Okay, differentiated. Now we were over here. Uh, 2 we will not differentiate this 2 because it is in multiplication. That's all. Now next sin is it is possible to differentiate it. That's why I am doing it. Even you will differentiate it. Whatever is possible, you will differentiate that. So sin x clear, okay. Upon dx because in denominator we have dx. That's why. Next this 3 can be differentiated. And you know that this is a constant. This is nothing but this is a constant. Here we just apply this dy upon dx. Now we are going to apply formula of this differentiation. 2 will be as a differentiation of sin x would be cos x. Okay, cos x. And 3 is a constant here over here, so you know that what will be, so this will be 0. At the end you are getting 2 cos sec x. This is your result as output and this was your input. When you entered this input, you got this much output. Clear? This much output. Okay, it is done. This is done. We did one question based on multiplication and addition. This was the first rule. Now next, I have next question. I have next 5 ln x plus 2. 5 ln x plus 2. Look at over here. 5 ln x plus 2. First step is the dy upon dx. 5 is multiplication. This will be as ln x. Differentiation of ln x upon px plus differentiation of 2. Differentiation of now 5 has it. Differentiation of ln x is what? Always 1 upon x. Just reciprocal of this x. Next we have 2. 2 is the alone, it is a constant. That's why this will become 0 after doing differentiation. So it is nothing but just 0. Now you got 5 upon x. This is your final output of this input. 5 upon x. Clear? So that is how you will solve. This is a process to solve any question. Next little bit is a different from this. Little bit and then just a decimal number is coming as well as a fraction is coming. As well as a fraction is. But I am telling you, this is not a difficult. It is looking difficult, but reality is that it's not a difficult. Look at over here. Why here this number is in multiplication, and you know that whatever number is in multiplication in this case, whatever is a number which is in multiplication will be written as it. Okay, will be written as it. But this number is with addition, so this will be differentiated. Okay, dy upon dx. Clear? This is clear. dy upon dx. Now this will be as it cos x, okay, upon dx, okay, here 3.14 upon dx. Now apply this rule, this will be as it depreciation of a cos x, just opposite of it, into this is nothing but just a sin x, clear? Then we have a constant 0. At the end you are getting what 1, 2, 4 upon 3 sin x. 1.24 upon 3 into sin x. Okay, that's it. Next question, let me write. Next. This question. A is the number. Remember, A is the number, B is also number. Okay? A is the number, B is the number. But here A is the multiplication and B is with the additional operator. Look at over here. dy upon dx. Clear? A will be as it. It will be differentiated upon dx. Then we have b, differentiation of b upon dx. Here look at over here, a as it, this will be also as it, because differentiation of e raised to power x is always the same, e raised to power x. Then this will become 0. Here we have this output of this input. Next question, let me write. Next question. This y is aw cos x plus null 5. It is looking difficult, complex, but reality is that if we take one step first, then you will be able to take next step. Just like me. Here, solve this. dy upon dx. Okay. Here aw is nothing but just number, and this number is a multiplication, and you know what to do here. It will be as it aw, and here depreciation of cos x. Okay, aw will be as it depreciation of cos x, just sin x. Then we have this 0. At the end you are getting this much output, clear? This was very simple. one thing you will have to remember, if you are differentiating a cosec, then it will give you minus. Okay, it will give you minus. This point remember, minus. Clear? But when you are differentiating sin it, then in that case cosec will be output but with a positive. But here you are observing that cosec is being differentiated. In that case, in the result, sin x will be negative. Now next. This question. Look at over it. First step, dy upon dx. 2 is in multiplication. Will be as it. Depreciation of sin x upon dx plus a depreciation of pi. This pi is a number. It is a number. Now 2 as it. Depreciation of sin x is just cos x. Operator will be positive. Now next we have this 0. At the end we are getting 2 cosec x. We are getting 2 cosec x. Now over here in this, look at over here. What is happening? What is happening over here? dy upon dx. Okay. Then depreciation of dx upon dx. Then we have depreciation of e raised to power 2. E raised to power 2. As we know that depreciation of e raised to power x is same. Then next we have this. Here 2 is coming, but whenever a is coming, it will be written as it. E raised to power 2. Okay? Now look at how here a number is coming. These and both are different, sir. Both are different. Here x is coming, which is not a number, fixed number. This is some value as pi does have. Same, it has some value. Right? So that's why if this is a value, it is a number, then this will become 0. This will become 0. At the end you will get e raised to power x. That much. Now next we will take one depreciation and addition like that. This is that. this question, addition and the difference. Next, next, we have three questions based on this rule. Let's see what does the rule say. First question here, dy upon dx, we are going to differentiate this. So here the differentiation of x raised to power 2, then differentiation of this is sin x, this is sin upon dx. In the denominator, in the place of denominator we have dx. Now here differentiation of this x square is nothing but 2x, 2 minus 1 will be 1, plus differentiation of sin x is just cos x, cos x. Okay, this is your final output of this input. Next we have this, next we have this d upon dx, differentiation of x raised to power 2 upon dx. Then we have differentiation of sin x upon dx. Okay, then differentiation of 2. This is the first step. Now differentiation of x square will be what? 2x. Differentiation of this would be cos x, and differentiation of 2 will be nothing but 0. So at the final we are getting this much answer. Clear? Now next we have this question, dy upon dx. This is the correct way to write the steps. Differentiation of x raised to power 3, and then differentiation of x raised to power 2, then differentiation of ln x upon dx. Now in the next step we know that differentiation of x raised to power 3 is nothing but just 3x raised to power 2. Next we have 2x, then ln x is what? 1 upon x, 1 upon x. Now you have a equation. You can simplify it, but till now, right now this is our output for this input. Okay, and it is also a quadratic equation. Yeah, not quadratic equation. Yeah, it is looking. But we cannot say confidently that it is a quadratic equation because it is giving us a option to simplify this. After simplify this, if it is a becoming quadratic equation, then we can say that this is a quadratic equation, and quadratic equation can be solved, as you know. So here just we are applying differentiation rules as well as formula. Now next question will be difficult, but not a reality is that next upcoming question will not be difficult, but it will be looking difficult. this question. Here we have some terms which are fraction. Here it is. This was your difficult test, but we can convert it or simplify it. This fraction can be written as x raised to the power minus 2 minus 2. Clear? Then same here, this can be written as x raised to the power minus 3, and 1 is a simple. Now differentiate this dy upon dx, clear? Dy upon dx, clear? Now over here, differentiation of this, then differentiation of x raised to the power minus 3, then differentiation of 1. It will give you minus 2x minus 2 minus 1 minus 3, then plus minus 3 x minus 4. Clear? Then we have this 1, it is a constant, this will become 0. It can be simplified. Okay, here look at over here, minus 2x raised to the power minus 3, then we have plus minus, this will become minus 3x raised to the power minus 4. This is your final answer. In this question, our focus was on this. We converted this in this. We converted this in this way, in simple. If the question is coming like that, just to simplify this so that it can become simple, not a complex. Next question. This ln x plus ex plus cos x. Very simple. This is very simple question. Solve this dy upon dx. Okay. Differentiation of this ln x upon dx. Then differentiation of ex upon dx. Then differentiation of cos x upon dx. Clear? Now look at over here. Differentiation of ln x is nothing but just 1 upon x. Then we have a raised to power x. This is written as a. Next we have cos x, just minus sin x. Okay, minus sin x. Differentiation of cos x is always minus sin x. Now it can be simplified further. This 1 upon x, a raised to power x, then it will become minus sin x. It can also be simplified further. But right till now, this is our answer for this question. Okay, for this question. Question was saying just apply differentiation formula. That's it. Look at over here. Next question. this question. Now we have four terms. We have four terms. Depreciation of this x square, then depreciation of 4x, then depreciation of 2, then depreciation of ln x. Look at over here, it will give you 2x, it will give you 4, because depreciation of x is always 1. X is always 1. Now next we have depreciation of 2 is 0, and depreciation of this 1 upon x. What is happening over here? 2x plus 1 upon x plus 4. This is your answer. When you will depreciate this, then it will give you next output. Next output. Clear? Next question. It can also be a differentiator. Two x upon x. Then depreciation of the x raised to power minus 1. Then depreciation of 4. Here it is giving you 2 and it is giving you minus 1 upon minus 2 plus 0. So minus x raised to power minus 2 plus 2. This is your next depreciation of this. Okay, let me write next question. Next question. What if functions are in multiplication, then what to do? If functions are in multiplication, then write equation this equation. Here we have two terms which are in multiplication. In that case, what would you like to do? Here, look at over here. First is x, then second is sin x. But remember, x is not number; it is a variable. X is not a number; it is a variable. First, you can consider it as a u and it as a v. First will be as it and second will be differentiated. Then in the next, after applying addition operator, then first differentiate this, then it should be as it. Then in next differentiate this and it should be as it. That is what I am saying. Okay. Here dy upon dx, this x as it, but it will be differentiated. So into depreciation of sin x upon dx plus. Now in this term we depreciated this sin x but not x. In this side we will depreciate this but not this. So sin x will be as it, and we will depreciate this part, this term. Okay, this term. Now x is in multiplication. We are not differentiating x. That's why it will be as it. X and then depreciation of sin x is just cosec x. Then we have sin x. Then depreciation of x is just 1. It is just 1. At the end you are getting x into cos x plus sin x plus sin x. This is your answer. Clear? This is your answer. Okay. So here we have a function which is in multiplication. Then how to solve this like that question? Just differentiate, not differentiate first. Okay, don't differentiate first. Differentiate next term. Then after applying addition, then differentiate not differentiate second term and differentiate first term. First differentiate, then next don't differentiate. After applying addition operators, then don't differentiate next term, second term, differentiate first term, as I did here over here. Now next, same over here. We have two terms. Not two terms. It is one. But we are considering that yes, this is a two term. First will be depreciated. No. First will be written as it. Second will be differentiated. This addition is coming because of it is a multiplication, that's why. Ax will be as it d into x raised to power 2 upon dx. X square depreciation of dx, depreciation of a raised to power x is just the same, a raised to power x. Then this will be as it depreciation of x square next to 2x. So here ex is common. Ex is common. X square plus 2x. This is the final answer. It is the final answer. Here you can see. First I did not differentiate this. I differentiate this is second term. And the next term I will, whatever I did not differentiate in this will be differentiating here in this. Okay, that's it. Now next. Sin x into cos x. Sin x into cos x. Look at over here. Sin x into, okay, first as it cos x upon a plus cos x into depreciation of sin x. Now this was the rule. Sin x as it cosec is depreciation of a cosec is minus sin x plus cos x as it depreciation of a sin x just cosec x. Now here sin x times sin x will give you minus sin x square, and this cos x square. It can also be written as cos square x minus sin square x. This is your final answer. This is correct answer. Answer which came is correct. Next question. This is the next question. First as it, second will be differentiated ln x upon dx, then this will be as it, ln x will be as it into d raised to d into x raised to 2 upon dx. X square as it, depreciation of ln x is just 1 upon x, just 1 upon x plus ln x into this will give you 2x. This one will cut. We have x plus 2x ln x. This final. Next rule. We are going to pick up next rule. If a functions are in division, in that case, what to do? In that case, you will have to do one thing is that first differentiate this, and it should be as it. Look at over it. Differentiation of this. First, this denominator should be as it, and differentiation of this u. Clear? Here we have a division. That's why operator will be negative. Now, here we did differentiate this. In this case, just opposite of this. U will be as it, and depreciation of b upon dA, and this upon v as well. This upon v as well. This is what is the rule of depreciation. If functions are in division, like that. If a function are like that, then you will have to solve in this way. In this way. For example, question is y is equal to x raised to power 2 upon sin x. Okay, upon sin x. Just a simple. This is question from my side. If a question is like that, here you can see it is this function is in division. Then just let's apply our solve this here dy upon dx here. First this will be differentiated but not this. So sin x will be as it differentiation of this x square upon x minus x square will be as it, then differentiation of sin x, differentiation of sin x upon dx. Now this upon this denominator square, this denominator square, but here we are not differentiating this in this denominator, sin square x. So sin x will be as it, differentiation of the x square will be 2x, will be 2x minus x square, then differentiation of sin x is nothing but just cos x upon sin square x. Nothing is common, so till here this is our output. That is how you will solve if a functions are in division. That answer is correct. No, next question, let me write here over it. This question. What is happening over here? Dy upon dx, then differentiation of this x square plus 1 upon x, then we have subtraction x square plus 1, then differentiation of x upon x square. Okay, we applied rule. Let's apply formula of differentiation. X will be as it, differentiation of x square 2x, 1 is a 0, so 2x minus here x square plus 1, then this is how much, differentiation of just x is a 1, x is a 1, and this is upon x square, so it is becoming how much, 2x square minus x square plus 1 upon x square. Nothing is common, nothing is common. This is your final answer. After applying differentiation formula as well as the rule. Now next question is that this question here. It is looking difficult, but reality is that it is not that much difficult. Look right over here. dy upon dx. First, we will differentiate this. Differentiation of sin x, clear, minus. Then we have sin x, clear. Sin x, differentiation of x plus 1 upon dx. This is upon x plus 1 square. It is what? A plus b square, yeah? Yeah, you can apply here algebraic identity. Let's apply the differentiation formula first of all, then we will solve this. Here, x plus 1 as it, sin x will become cos x, clear, minus sin x, it will become 1. Now we are able to simplify it. As you know that it is nothing but x square plus 2x plus 1. After applying algebraic identity, it is giving you this much. Okay, now x plus 1 into cos x minus sin x upon x square plus 2x plus 1. This is our final output. Final output. It can also be differentiated, but till now, till here, this is our output. This is our answer for this question. It can be differentiated further, but just first times we had to differentiate this. That's it. Now next. This is question. We have this u and this v. dy upon dx. Okay. This as it differentiation of this u x3 plus x square upon dx, because in denominator we have this. Next minus, then x raised to power then x square. Okay. 1 plus x upon dx, differentiation of this. Upon 1 plus x square. 1 plus x square. This 1 plus will be as it. This 1 plus x will be as it. Next we have this differentiation. It will become 3x square and this will become 2x. It is as it. Then we have this 1 0 and differentiation of x is just 1, and this is upon this much. Here algebraic identities can be applied, that's why we will apply it over here. 1 plus x, so it is nothing but x square plus 2x plus 1. That's it. Till here, this is your answer. This is your answer. Let me write next question. This e raised to power x upon x. It is very easy, isn't it? Dy upon dx, dy upon dx. Okay. Then we have first differentiation of this u. Carefully take next step. Your focus should be on solving it, not on another person. Okay, this is done. It is upon dx minus e raised to power x, then differentiation of x upon x. This upon x square. Clear? X as it differentiation of this e raised to power x is same. Then minus e raised to power x, differentiation of the x is just 1, and this upon x square. Here e raised to power x is a common. X minus 1 upon x square. This is our final answer. Answer is ax into x minus 1 upon x square. Next, sin x upon cos x. Next is what? Sin x upon cos x. Solve this. What will happen? Dy upon dx, and then here cos x as it sin x upon dx minus sin x into the differentiation of cos x upon dx. This is upon cos square x. Cos x will be as it into sin x will become cos x, then minus sin x into cos x will become minus sin x, minus sin x. This is upon cos square x. Here it is nothing but cos square x minus minus will become plus sin square x upon cos square x. Here you can apply trigonometric identity. Trigonometric identity say that it is equal to sin square x plus cos square x is equal to 1. And here this will give you nothing but 1 upon cos square x. Here you know that this is equal to sec square x. You know that this is equal to sec square x, isn't it? Till here this is also answer, this is also answer, this is also answer. It is your choice. Either you can stop on here or on here or on here. This is your choice.